Okay, here in front of me I have a variable AC power supply, which is called the Variac for Vari AC. So I've built this back in 1997. The transformer itself, okay, is an 8 amp. It's an 8 amp rated transformer, and this is a Crompton meter, which I put my own numbers on there, numbering, and you can see there JF Electronics 1997, and I have put a scale, okay, with the knob here to change the scales manually. And then I have a voltmeter, a digital voltmeter, which you can change, and it goes about around 260 mark there. Okay, and that's a fuse there, because the way the scaling is done with a current transformer. And this way, why this current transformer was that it's right at the back there, okay, underneath these relays which switch each scale. So the secondary of the transformer runs the meter here on these 2 points, and the primary, you wind the wires and the bottom. We should give you sort of a better view there maybe, okay. And so the primaries are the scales. So you have one winding, one coil for the 0.5 of an amp scale. Then you got another winding for the 1 amp, and then 2.5 amps and 5 amps, and then you have another winding for the 10 amps. Okay, so that's how it's been made. And then you switch the windings. One relay will come on, the other one will go off, and so on. So I've got 5 relays for the 5 scales. So what I'm going to be doing on it, I'm going to give it a bit of a new look to it, and some new components, where it's going to have an LCD screen here. So it's going to read the same, the voltage, but I'm going to read the current as well, and then it's going to give out a watt reading. And I'm going to have a circuit breaker, a digital set circuit breaker, so we'll be able to switch the current, set the current I mean, and we'll be able to set the time, so milliseconds, on how long, when the current is stripped, how long will it take to trip the circuit breaker itself. So I have seen some circuit breakers on YouTube, people that made, for example,
Ron from Glasslinger.
I think he was the first one to actually make one. So it's similar, but mine is fully digital control, including the current settings. So the increments that I'm going to have, it's going to be changing the current setting, like 1 milliamp increment up to 10 amps. So I mean, this unit is rated at 8, and but for scaling, you know, we'll go from 1 milliamp to 10 amps. So later on I'll show you the circuit that I've designed, and how we're gonna make all that work. Okay, so that's the first video. So here I'm gonna be dismantling the whole meter, the whole instrument, and so I can redo it all up. So just remove the screws for these relays here, so everything's gonna look like a mess. It wasn't built that what do you call it, that neat anyway in the first place, the first time. But at the time, back in 1997, I didn't even make a circuit diagram. So I will be showing a circuit diagram how this was. I'll make one up when I take it all apart. So I'm in the process of dismantling it. So this is the current transformer. So remove the terminal connection. I mean, these terminals, I even soldered them, so some things I did was pretty good. So I thought I'll just film this just to show an idea how it was. And of course I'm still going to be using this transformer, so the current transformer anyway. It's just I might be mounting things a bit differently, and so I don't think I'm going to be using these relays, though they have served me well. I have been repairing TVs and videos and electronics repair for, you know, 25 years, and of course I have stopped a long time ago now, but these relays, they are Matsushita, Japanese. They were rated at 5 amps, and I think what I did is, because they were a double throw, I used the other contacts in parallel, and it still served me well. I mean, I could see there a bit of an arc. So anyway, I might be replacing these and have a different system. And so the meter. This was, look, a Vera board that I did. This was just to replace the not to replace, it's just to power up the digital voltmeter, and to get low voltage DC to run the LEDs because I modified this meter to put LEDs in it, the analog meter. So yes, this is a very excellent meter. And so I remember it's a long time ago, I went to the company and I bought this from them, from Crompton, here in Australia. And it's a 1 amp, that's what it says here, because I sort of forgot. Yeah, it's a 1 amp scale. So this is, if you put 1 amp across the moving coil there, okay, it's actually not, it's a fixed coil, it's not a moving coil meter, but if you put 1 amp, you'll get 1 amp full scale. So then the current transformer, right, at each scale, I'm always getting 1 amp full scale across the terminals, which is across the winding inside of the meter here. So reason why I done this, of course, and as you can see there, the meter, sorry, I'm not even showing you, I wasn't even looking at the camera. So there's the meter there, and I modified this, as I said, and I've put LEDs in it, and I've put the numbering back in 1997. But also, it's got a stamp here, and if my camera can focus, which normally the cameras on Samsung cannot focus, not unless it's a human being. And you will see that it's stamped back in 1997. So that's when this was made, and that's when I built the power supply. And so yeah, where was I? 1 amp full scale deflection. Okay, so the current transformer, what it does is on each scale, okay, it's dividing to always give me 1 amp. So at 10 amps, then I'm dividing it by 10. On 5 amps, I'm dividing it by 2. Sorry, by 5. What am I talking about? And so on, as you can see. I haven't planned in writing this down, so few errors while I'm talking here. So anyway, I'm just going to dismantle the whole thing, and then we'll take it from there. So I have removed this section. Okay. What else I need to remove? So I think I'm gonna be, this is the this is the voltage input to the digital meter. Gonna have to cut that. And the way this was scaled was used a is it so 1, 2, 3, 4, 5. So it's a 5 position rotary switch, and it's a double throw type of switch, which is separated, right? So it's got 2 circuits on it. So 5 positions, one section of it is a 12 volt system, and the other section, if you could see, it's a 240 volts, which I did. So the first 5 position, one side switches the LEDs, just changes the LEDs on the meter, okay, for the scale, so you know which scale you're on. And the other 5 will switch the relays. So that's how I wired it, but I will make a circuit diagram and show you. And this idea, by the way, this idea of having LEDs, okay, in the meter, I have learned this when I was an apprentice working for a person that fixed TVs and videos. His person is the smartest electronic person that I know, and his name is Rodolfo. And he used to put this on his power supplies, where he put an LED for the scale. So, you know, and he built it in the meter. And I always remembered that because I liked it very much. And I have done that to my analog meters on power supplies. So, yes. So it wasn't actually my idea. But my idea is, which I'm going to have is, at the moment, the way the circuit is, I'll switch the scale manually, right? Yeah. And I already have done this new idea on my DC power supply. But what I'm going to have is, since now I'm going to have a digital readout of the current on a LCD display, right? I'm going to have the scale switching automatically. So once it goes to over 0.5, it'll switch to 1 amp. It goes over 1 amp, it's going to switch to 2.5 amps, and so on. Over the 2.5 will go to 5, and then to 10. So I'm probably not going to have a manual settings anymore, because I probably would put the manual settings in a digital format. I can do that, but I don't think I have enough room in the front face of the case of the power supply to have extra manual settings for buttons or rotary switches. But the idea is also going to be that it's going to be switching automatic. That is my idea. Okay, so we'll keep on taking it apart. I think I'll take the fuses off. There's the power side of it. Display, what else I have here? This was the input, and this is a ground, earth. Okay, and this back section here is actually from a microwave oven. I never used to throw things out. I'm always looking to reuse parts from appliances. This is the one of the fuses here. So be disconnecting that. Now, I don't know if this was soldered. Section of it. Looks like that it was. This resistor here, I don't know if you can see it. Yep, this resistor was to lower the voltage on the AC, because these relays are AC relays, because I think they rated it, let's see, so the coil of the relay is 100 volt rated coil. Of course, I had these. I can't remember where I got them from, but so you have to put a limiting resistor to lower the current, and then it will actually lower the voltage. Okay. Okay. Okay, so one fuse, so I probably will reuse these. And because they are soldered, I know I would have to cut these off to be able to take them off. So just cut them. Take the tape. In those days, I don't think I had all the sizes of featuring, so I just put tape. Geez, with this tape, it stuck pretty well and left the glue over there. So I had the thread. I will clean them up when I come to put them back. Okay. this probably really I shouldn't have done it in this way, but back then I thought it was good. So that was, you can see this is from a microwave. A lot of the microwave systems are like this when the power comes in. Okay, and it clamps the input mains cable, and then it's got a connector, and then it's got an inline fuse here, which I used as well. So I had about a fuse there, which probably I set at the highest, and then I had two other fuses here. One was for the a fuse for the supply to the coils, relays, okay, and probably the supply to the circuit here. And then I had a fuse to cut the current, the main to the transformer. And I had a fuse in the front to protect the first winding, which was for the 0.5 amp scale, the 500 milliamp scale. And the reason why I did that is because I used a small gauge wire to be able to wind all these windings on the current transformer, because I could not fit it. So I used a smaller wire because it was for the smaller scale. Now the reason why I did this system is so when I switch between scales, it doesn't matter, okay, if the contacts on the relays are not making the best contact that it can make. That means the current that I'm reading is always going to be accurate, because if the contact of the relay is not it's got high resistance, for example, there, okay, obviously the current is going to be lower. And so then, because it's in series with the primary of the current transformer, it's going to show me what the actual current is, always what the actual current is running. So that is why I chose this system. So I'm always going to read the accurate current. So if you don't do it in that way, if you have bad contacts on your switching from one scale to another, you will get an error, okay, on your actual current of the load that you have put on. So the load goes through the relays and goes through the primary of the current transformer. Therefore the secondary is going to give me the true current draw of the load, if you could understand that. So this is why I have designed it that way, because I like to have accurate readings, where you can buy other instruments and they might not be even done this way. So yeah, okay, that's one phase. So now I've got this cobweb of wires here. What else I have to change? So I don't think I want to take any more there. So I will remove the transformer and the rest of it. So I'm going to pause it a little bit because it's going to be too long, and then I'll continue on. Okay, and here it is laid out. So as the case, to be honest with you, the case was too small really for this large frame auto transformer or Variac. It's well made, and I think it was made in Slovenia, and you can see there, okay, by, what's the brand there, Material. See, it's rated 260 volts, 8 amps, 240 volts input, 50 or 60 hertz. That's the diagram. Okay, there's the wiper at the top, and you can see here it's a nice carbon wiper, spring loaded here. There's a spring inside, and a nice flat machined windings. You can see where it actually used to rub. Okay. The only thing I don't understand is why it had to be such a big core on it, and very, very heavy. So there's the current transformer, which is a Crompton one as well, made by Crompton. I bought it from them. And you see where they've wind the windings here. Okay, so at the back here you can see 5 amp scale, the 10 amps and the 2.5 are wound on this part. Okay, this is a toroid transformer. So I got the three scales there, yeah, 5, 10 and 2.5, and then I've got the 1 amp and the 0.5 amp coil one on this side. Now, because of course I had to do more turns on the 0.5 to create a 1 amp. Okay, so when it's 0.5, then it's 1 amp up the top on the secondary. Okay, secondary. It means you need more turns, and of course, let's say the 10 amp scale will be much less. And so, because I couldn't fit it in, okay, I had to use a smaller gauge, and therefore, in series, okay, I think I put a 2 amp fuse in series with the 1 amp and the 0.5 turns. Okay, but the windings on the 2.5 and the 5 and the 10, the gauge wire I've used can handle more than 10 amps, so that's okay. So I probably will have to keep that. I'm not going to be rewinding this, not unless I want to do calibration, but I did that back when I wound it, the calibration to how many turns. Here's the relays there. That's the another transformer just to get 12 or 9 volts. I put 9, so it's got 9 volt regulator. I'll make a circuit to how this was, and there's my meter there. So yep, we'll continue on. Okay, here I have the Variac case without all the parts inside, without the internals, and I'm gonna have to make a new front plate, because some stuff will be mounted the same, but here we're going to have an LCD alphanumeric. So I said LCD before, but it's an LCD alphanumeric screen, and the switch and the controls is different to what I used to have before. And of course I'm going to have to make a new front screen for the Variac control. So here what I have is some aluminium plate, which I have cut already with the jigsaw. So I measured it up, and I have this plate, which is going to go in front on there. So what I have to do now is, on the computer, I have to design a front screen which will be a sticker, a vinyl sticker. And but first I'll have to print it out on paper, so it gives me all the points where I need to drill the switches, holes, and etc. for the analog meter, the alpha LCD alphanumeric screen, the off and on switch, controls and all that. And also it's got to have the new marker for the voltage for the Variac. So that's going to be all on the computer. So I'll show you that now. Okay, so there it is there on the screen. Of course, I've already started this. It's a printout, so I can put that on top of the aluminium sheet. It actually goes like that. I got it upside down. So this is a software, free software called Front Panel Designer. It's actually made to be by a company that then you will have your aluminium engraved, sent to them, and they'll buy a machine, they'll do it for you. But I actually use it just to print on paper or on vinyl paper. So of course I had to create this the degrees here for the voltage scale, and of course the original sticker, it had 27 points, but the divisions here from 0, I'll try to focus on this section. If you notice here, 0 and 260, you can fit another 2 portions there, which will give you 29. So then you get the calculator, okay, and you do 360 for 360 degrees, full circle, divided by 29 will give you 12.4137931 degrees. So each line, so each 10 volts is 12.41 degrees, pretty much, okay? And then I looked over on the internet to see what I could find, and I found a website. Well, I found an article, how to make a protractor, and just looking at the front panel for the Variac instrument that I'm rebuilding, just something occurred to me regarding the voltage screen. So that's going to have that there for the Variac, and you will turn that to adjust the voltage. Is that the numbers here, if you start looking from the 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, then the numbers are always in the direction from the bottom to the line. And then really to the eye, they're really upside down, aren't they? So this half, the bottom half, the numbers would look upside down. And then from the top half, they look okay. Now, depending on how you will look at the sticker, so I mean the graph of it's not really a graph, but the picture of it, if you keep rotating, they're always going to look correct, right? So if you rotate that, they're always looking right because they are corresponding with the line when it was made. But to the eye, you're going to set your instrument in that way. You're not going to set the instrument flat down this way. And even if you've set it flat down, you're still going to have the eye problem. Looking the bottom half, the numbers are upside down. So you know something? I mean, the original sticker made for the Variac, that's the original sticker of the transformer when I bought it. That's what was given. It's done in the same way. The numbers from bottom half, they would look upside down. Now, you could say, well, there's nothing wrong with that. And really, I never really took any notice in the past. But now that I am taking notice, maybe because they only put, if you notice here, 10, 20, 30, sorry, 10, 20, and then they done the 30. So they're jumping 2 and 30, 60. So there's not much numbers there. And maybe it doesn't look that bad to the eye. But when you're looking at every 10 volts, there's a lot of numbers there. And because there's a lot of numbers, I think to my eye, it's sort of annoying me. I would like to see the numbers looking in the correct way, which is not upside down. When I'm looking at it in this direction like that, I don't have to twist my head around to look at the number properly. So you know something, I went back to the original source file under the Word when I created it, which thank God I saved it, and I've already started to change them. So if you noticed, the 70, getting back to this, okay, it's still in the same direction. And then the 80 is this, yeah, 90, they're all the same, right? But now here, if you notice, after the 70, now I'll cross the halfway point where my eye is looking at this to the bottom. And I'm changing the angle back the opposite way. So I've changed the 80, the 90, 100, now to the eye. That's looking much better, right? The 130 I haven't changed yet. So click on the 130. I go to Format, Angle, 90 degrees. Click 90 degrees again, rotate. And now that's the 130 that way. So I'm going to change the 140. Format, 90, 90. Change the 150. Format, 90. And I think I like this idea better. Now you see, I think that's better to the eye. When I look at the top half, it looks okay, and I start looking at the bottom half, that's looking good. So I'm going to change all of them. Okay. I'm just changing 180 degrees each one. So I got to do 90 times 2. This also. Now, I think I'll leave the 220 as it is. Yeah, so I think I'll have it like that. 220, I can see my eyes. Okay. 230, 240, 250, 260, 10. Now, this of course all depends which way you will have this. If you rotate this, let's say halfway or 1/4 out, it's going to make the numbers wrong again, some of the top ones. So you have to decide how you're going to have the coordinates, whether you're going to have 0 at the top, 90 degrees at the top, okay, or I mean 0 degrees at the top, probably should say, or 360. And yeah, so I think I'll have it like that. Yeah, I think that's much nicer to the eye to look at. So I will save that. Well, before I save it, I gotta do select all objects. I gotta, hang on a minute, select all objects. Oh, it's not letting me do that because I wanted to group them. That's okay. I will regroup. So I regroup them all, and I will save it as it is. So now I think what I did originally, I go save as, and I'll save it as a PDF. Save. Replace the one that was there. Okay, that's the PDF. Now I will use Photoshop. Okay. All right, I had a bit of an error. I had to redo it again. I'm just going to crop this. Just hope I haven't missed any numbers. Do this again. I'll do crop. It's so close to the bottom and to the side. I'm not sure what's going on here, but I think the computer here is or maybe what I should do is make this smaller, insert, okay, that comes up, import, choose your file, open. Okay. Okay, so what I'm going to do is I'm going to see if this size is going to go over to the right size. Let's see. Get a bit bigger. Proportional. Scale proportional. So I got a tick proportional there. So when I make it smaller, it's gonna keep it in proportion of the original file. And let's make it a bit smaller and remeasure. I need to look at, I think, let's see, 109. Now I got 109. Check the old one again. Was that 102? Almost there. Slightly a bit smaller. Reduce it a bit more. We'll measure it again from the edge of 220 to the edge of 80, 107. Check the old one, edge of 220, so I got 107 on the old one, 103. It's still a bit too big. Okay, better make it the same because I was happy with that. Okay, let's hope it's not too small. So I'm looking at about 103. Let's see what we get there. 105. You know something, I think I will be happy with that. So undo move. I'll remove this, the old one, and now in place I'll place the new file. Okay, there's only 3 mil difference, but it's in proportional, so it should be okay. So now I've got it where the numbers are nicer to the eye, where the bottom I don't have to look funny with upside down numbers. So that's the way I done it, and then of course I'll do some little minor adjustment now to put it exactly in the center of that point of my hole there. So that's that part.